Today in the workshop, we're setting up WLED. You'll see how to install WLED on an ESP32 to build a sophisticated LED strip light control without a single line of code. We'll also set up audio reactive to control our LEDs with sound. It's a pretty flashy episode today, so welcome to the workshop. Well, hello and welcome to the workshop and to a very colorful edition of the DroneBot Workshop, because today we're going to be working with WLED. WLED is an open source product that runs on an ESP32 and allows you to control LED strips, just about any type of LED strip and just about any length of LED strip. This wonderful product also has a web-based interface. You can use an app to control it, or you can control it with a number of IoT platforms, including Home Assistant. One interesting thing about WLED, however, is that the LED in its name actually doesn't stand for light emitting diode. So let's go learn a bit more about WLED. WLED is actually an abbreviation for Wi-Fi Lighting Effects Driver, but of course it has the name LED within the acronym. It was created by Christian Schwinn, who goes by the name of AirCookie, in 2018. WLED is an advanced controller for addressable LED strips as well as non-addressable LED strips. The product is based upon the ESP8266 and ESP32. Note that the ESP8266 is at the end of its service life and should not be used for new projects. WLED requires no code. You use a web-based interface to load the product onto an ESP32. It comes with a web browser interface, and there are also mobile apps available. WLED has an extensive effects library. WLED allows you to divide an LED strip into different segments. You can also synchronize multiple WLED servers. The product can be connected to other products through its API support. WLED can be interfaced with many smart home systems, including Home Assistant, the Amazon Alexa system. It can be interfaced with MQTT for advanced configurations, and it's also compatible with the Philips Hue Hub. In this video, we're going to install WLED onto an ESP32. We'll learn about the different types of LED strips that you can use with this product. We'll learn to safely wire those LED strips, and we'll also create an audio-activated display. So let's get started with WLED. So now that we've learned a bit about WLED, it's time to set it up. But before we do, we're going to need to select an ESP32. Now, not every ESP32 is the same, and some of them are better for specific applications than others are. So let's go and take a look at the criteria for selecting an ESP32 for use with WLED. When choosing an ESP32 for use with WLED, there's certain criteria you're going to want to take a look at. You'll want to see how much flash RAM your processor has. It requires a minimum of 4 megabytes, and most ESP32s will satisfy this, but more flash RAM can add for additional effects and more LEDs. If you're driving multiple strings with WLED or using some additional effects, you'll want an adequate number of GPIO pins. Not all ESP32s have pseudostatic or PS RAM, but those that do can have more effects and drive more LEDs. You'll also want to look for an ESP32 that uses a USB-C port. It's better than micro USB, which is just about obsolete now. The ESP32 WROOM32 is a good choice for WLED. It's actually the most widely used processor. It has 2 cores and lots of GPIO pins. On the negative side, it has no pseudostatic RAM and a limited amount of onboard flash memory. It also has higher power consumption than more modern ESP32s. This device is the best one for beginners and is good for small to medium projects. The ESP32 WROVER includes PS RAM and is a dual-core processor. It has flash memory of up to 16 megabytes. These are generally larger modules and they're more expensive than the WROOM32. This is the best device for a large-scale installation, such as projects that have over 1,000 LEDs. The ESP32S2 is a lower-powered device that has native USB support and improved security. It's a single-core unit, so it has lower performance, and it doesn't have Bluetooth. It's also not officially supported by WLED, but many installations have been done successfully with it. This could be used for simple projects and projects with limited effects. The ESP32S3 also has native USB and is a dual-core processor. Some models also include PSRAM. It has a higher cost, though, and has limited onboard flash memory. As with the S2, it's not officially supported by WLED, but it does indeed work. This is probably the best all-around processor for audio reactive projects. The ESP32C3 has very low power consumption. It has BLE 5.0 support, and it's small and quite inexpensive. However, it does not have PSRAM, and it's a single-core device, so it's lower performance. Once again, it's not officially supported by WLED, but it will work. This is probably the best budget microcontroller and is good for very simple LED projects. So given this information, you should be able to choose an ESP32 for your WLED project. And here's the ESP32 that I've selected for my WLED experiments, and it's an ESP32 dev kit. It's a WROOM32 or Room 32 if you prefer, and it's a nice little dev kit. It's got a USB-C connector, and I have connected it now up to my computer, and I've gone to the WLED web installer page, and it's a very simple installation. All you need to do is literally hit the install button, and you select the port, and you can see it over here. It'll be the USB to UART bridge controller, and I'm going to hit connect on that. I'm going to select install WLED. I'm going to confirm that I want to install it. It's going to do some preparation, and it's going to install, and it says it's going to take about 2 minutes. Now, of course, since this is video, we're going to do the magic of video and make that 2 minutes go a lot quicker. Okay, so my installation is complete, and I hit next, and it now wants to configure the Wi-Fi. Now, this is an optional step. If you don't want to connect the Wi-Fi and instead you'd rather use an access point, you don't need to do this. But I'm going to bring this onto my Wi-Fi network, and so I'll give it my password. And it's connected to the network, and now I can do a number of things. If I have Home Assistant, I can add it to Home Assistant, or I can just go and visit the device's configuration page, and so we'll do that. And it loads the WLED user interface, and here we are in the WLED user interface. And that was a very simple installation, wasn't it? And so let's take a peek around the user interface. Now, obviously, we can't really use it too much because we have no LEDs hooked up at the moment, but we can at least see what's available to us. Now, this screen that we're on, we're going to come back to later because this, of course, is where we actually control the LEDs that we currently don't have hooked up. You'll see there's a number of different options up over here, and the two I wanted to look at were info and config. So let's go into info here, and it tells you things all about the ESP32 that you've been connected to and about your signal strength, etc. You can also update WLED software from here, and you can reboot it, and that's a handy feature because there are some configuration changes that require a reboot. Now, I wanted to go into the config screen, and there's a number of options in the config screen. For example, you can go into user interface, and you can set the options on the interface. So if there's things that you want to change, you can change them. You can even put your own background image and everything. So they really have thought of a lot of different things here. Now, the LED preferences is where we're going to visit after we hook up some LEDs, because we need to tell it what it is we're driving, the total number of the LEDs, the type of LEDs, and the GPIO pin that we're going to hook the LEDs up to. This has a number of other options as well, too. If you look down over here, it's got options for what to do with the different GPIO pins. It can be configured as buttons, and you can use a number of things on them. This first one over here defaults to a push button, but you've got lots of other different options as well, including a PIR sensor. So you could have lights that come on when the PIR sensor senses somebody. So there's a lot of great options here, and you can go down and see that there are even more options for the lights here. It is very, very sophisticated. So WLED is now being installed on my ESP32, and I think it's time to go and hook some LEDs up to it. Okay, so now we've set up an ESP32 with WLED. It is time to now look at what kind of an LED strip we can drive with this product. Fortunately, we can drive just about any type of LED strip, but there are differences, of course, between the different LED strips. And just as with selecting an ESP32, some LED strips are better than others for specific applications. So let's go and learn a little bit more about selecting LED strips. We can divide LED strips into two different categories. Non-addressable LED strips have all the LEDs wired in parallel. In these strips, all of the LEDs behave the same. You'll drive these with a MOSFET, as you need to be able to handle the current of all the LEDs with your driver. Non-addressable LED strips are used for very simple applications. With addressable LED strips, each LED has a driver chip. Each LED has its own unique address and can be driven independently. You drive addressable LED strips with a digital signal. These can be used for complex displays, and they're the type of strips that we're going to be using today. When you're looking at LED strips, you'll see a number of designations to indicate the colors they can produce. An RGB strip has 3 LEDs per pixel, a red, green, and a blue. RGBW adds a single white LED, and this can be a cool white, warm white, or neutral white LED. RGBWW LED strips add a warm and cool LED to the same chip. RGB plus CCT adds a correlated color temperature white LED. You can also get single color and CCT only LED strips. One very popular LED strip is the WS2812B, also known as a NeoPixel. This is a 5-volt device with a single wire data line. It's got an integrated LED driver and RGB LED in the same package. These are very common and inexpensive, and they're supported just by about everything. However, they can be sensitive to voltage fluctuations, and they can have a very short maximum data length line. The WS2811 is a chip that drives LEDs. These are typically for 12-volt strips, although there are some 5-volt versions. They use a single wire data line at about 800 kHz. This is an external driver IC that can control a group of 3 LEDs. It's great for long runs, and there's less voltage drop with a 12-volt system than a 5-volt system. However, it has limited resolution, as one IC often controls 3 LEDs simultaneously. The SK6812 is a 5-volt LED that has a single wire data line. It's available in RGBW versions with a true white LED. It has cleaner whites and better color rendering than the WS2812B. However, it's slightly more expensive than that LED. The WS2801 is also a chip that runs at 5 volts, although some 12-volt ones exist. This is controlled by 2 wires, a data wire and a clock wire, kind of like an SPI bus interface. It features independent RGB control and better timing tolerance. It's more reliable over long distances, and it's less timing critical. However, it's higher cost and has a lower refresh speed compared to some newer LEDs. And the APA102 is also known as the Dot Star. This is a 5-volt LED that uses 2 wires, a data and clock, and an SPI-like interface. It features 8-bit global brightness and 5-bit per color control. It has a very high refresh rate, and it's very good for persistence of vision or POV projects. However, this is more expensive and draws more power compared to a WS2812B. Another rating you're going to see with LED strips is the IP rating. This is the ingress protection rating. This indicates how an LED strip is protected from its environment. The first digit is solid particle protection, and it ranges from 0, which is no protection, to 6, which is dust tight. The second digit is liquid ingress protection and ranges from 0, which is no protection, to 8, which is prolonged submersion. One common rating is the IP30. This is for objects larger than 2.5 millimeters, and it isn't dust resistant. It's vulnerable to humidity and spills and should be used indoors in dry areas. As a bonus though, these are very easy to work with, especially if you have to cut and solder them. The IP65 is fully protected from dust and is protected from rain and splashes. However, it's not submersible. This can be used outdoors. These are a bit harder to work with because you have to cut through the coating, and the coating can also diffuse the light from the LEDs. And another specification when choosing LED strips is the density, how many LEDs per meter. These have several popular densities, including low density at 30 LEDs per meter, medium at 60, and high density at 120, but there are other densities as well. For example, 144 LEDs per meter is also very common. So take all this information in mind when choosing your next LED strip. And here we have a selection of LEDs, all sorts of LEDs, and one thing in common with them all is that WLED can drive every single one of them. Now we're going to start off over here with a non-addressable LED, this one over here, and this is just an RGB strip, so you can see it's actually got 4 conductors, the red, green, and blue, and the common conductor, which I think is actually positive, not negative on these things. And this, of course, can be driven by WLED, but you need a different hookup. You need MOSFETs in the hookup because it has to be able to handle the current of all the LEDs on the strip. And this, by the way, is the way a lot of strips are packaged. They're packaged in reels, and so they're very convenient. You can buy a bunch of these things and store them quite easily. Now, this is the strip that we're going to be using today. This is an addressable LED strip. It has NeoPixels in it, and it's got 60 LEDs per meter, so it's a 1 meter length with 60 LEDs on it, and it's got a connector on the end, and it's a pretty standard connector, and I'm going to be using the mate for this connector to hook everything up to the solderless breadboard, so it's a lot easier than having to solder these, and these connectors are quite durable. In fact, when I had to take 2 of them apart, I had to struggle with them, so they do go on there very solidly. This is an LED matrix, and it's got 64 LEDs, and it can also be used with WLED. It's basically just like this. It's the same NeoPixels, except there are 64 instead of 60 of them. If we look on the back of them over here, you can see you've got the connector here for the input. It'll cascade, so you've got another connector in the output. And they also bring out a power connector over here, and this is if you want to do something called power injection, and we'll talk about that in a little while. It's a way of adding extra power to large LED displays. And we're going to take a look at this matrix display a little bit later as well. And these are NeoPixels. These are round NeoPixel displays from Adafruit. On the back over here is how you solder, and they've got the connections in the corner for all the different places. Again, they're treated just like these displays, and WLED will drive them. They'll drive this. You can cascade them and make some kind of a neat display with that. And it's just a small sampling of the types of LEDs that you can drive with WLED. Now here at the DroneBot workshop, we've worked with LEDs many times, but the LEDs we work with usually are being driven by individual GPIO pins, and they only consume a few milliamperes of current. LED strips are a different story. A good size LED strip can consume a couple of amperes of current, so you'll need a power supply that can supply that. You're also going to have to be very careful with the wiring, and it's mandatory that you use some sort of a fuse to protect yourself, because current like that could actually be a fire hazard if you have a wiring error. So WLED themselves have issued a number of excellent wiring guides, and I certainly couldn't do any better than that. So let's go and take a look at a few of their wiring guides, and then I'll show you how I hooked up some LEDs to that ESP32 that we programmed, and we'll start making some pretty lights using WLED. And here are the WLED wiring guides, and as I said, they're quite extensive. We'll scan down them, and then I'll show you a few specific ones. We start off with the addressable LED strips, and they go through 5-volt ones, 12 and 24-volt ones. They show you how to wire up multiple strips, and they also show you something called power injection, and I'm going to show you all of these in detail in a moment. They also cover the non-addressable LED strips, in other words, the ordinary strips. You'll notice these make use of a MOSFET to drive the LED strips, and here's one that's RGB, so it needs 3 different MOSFETs. Now here's one of the diagrams, and this is a standard 5-volt one, and this is the one that we're basically going to be following today, and you can see the level of detail that they go through with their different diagrams. One thing I wanted to show you over here that you can see in this diagram is the way they distribute the power. Now they're exaggerating this because this is a short strip they show, but on a long strip this is not uncommon. They've taken the power and they've added the power in a number of different points here. In other words, they've paralleled the power with other ground and power lines, and this is a way that you can make certain that you're indeed getting 5 volts at the end of the strip as well as at the beginning of the strip. And here's a diagram of multi-LED wiring, and so we're using multiple GPIO pins from the ESP32, and we have multiple strips, and note that each strip is being fused individually. This is very important. Fusing is very important because, of course, we can draw a lot of current from these, and so this is a great diagram to be able to follow if you want to drive more than one LED strip. And finally, this is one that I wanted to show you because it shows something that's called power infusion. Now with power infusion, you can use multiple power supplies on multiple LED strips. And this is a good technique if you've got a lot of LEDs, because one power supply may not only have the current, the length of the strip, the voltage drop on it can mean that at the end you aren't going to be getting 5 volts. So you'll notice over here they've got a second power supply. In this case, they're driving 2 strips. And the 2 strips are connected over here, but there is no connection. If you look down here, no connection with the power. And that's very, very important because you got one power supply feeding it over here and another power supply feeding here. You cannot connect the 2 together. But this means these LEDs are powered by one supply and these by the other. Of course, you need to have the ground and the data pins connected through. And so with these wiring diagrams, WLED has really gone out of their way to make it very easy for you to hook LEDs up in your system. Now for my WLED hookup, I'm using an ESP32 WROOM32 module. Now you can use a different ESP32, but you may need to use different pinouts than the ones that I'm using. Of course, you'll also need an LED strip, and I'm using a 5-volt WS2812B. Any 5-volt LED strip should work, and the number of LEDs isn't really that important because you can set that within WLED. For the record, my strip actually has 60 LEDs. We'll also need a 7.4 HCT125N chip. Now this is actually a quad buffer, and those of you into electronics will note the 7400 number in there, as it is part of the 7400 series of logic chips. However, the HCT series are not TTL, they're CMOS, and they'll work from 2 to 6 volts, so they can also be used as logic level converters. These work much faster than the logic level converters that we've used before in other projects. You'll need a 5-volt power supply, and the supply should be fused. The rating of the fuse will depend upon the current draw on your LED strip. You'll require a 470 microfarad capacitor at pretty well any voltage, because we'll only be applying 3.3 volts to it, and a 100 nanofarad capacitor as well. We'll also need a 68 ohm resistor. We'll begin by connecting the 5 volts from the power supply to the ESP32's V-in pin. We'll connect the power supply's ground to the ESP32 ground. We'll connect the power supply's 5 volts to the LED strip's 5-volt input. And we'll connect the power supply's ground to the strip's ground connection. We'll also connect 5 volts to the VCC on the 7.4 HCT125N integrated circuit. And we'll connect the ground to the ground on the 74 HCT125N. We'll connect GPIO pin D4 on the ESP32 to the 1A input on the 74HCT125N. We'll connect the 1Y output from the integrated circuit to one side of the 68 ohm resistor and the other side to the data input on the addressable LED strip. We'll ground the output enable pin for gate 1 on the 74HCT125N, and we'll also ground all of the other enable and input lines on the chip. Do not ground any of the output lines or you'll destroy the chip. We'll connect that 100 nanofarad capacitor across the power supply line. The 3.3 volt output of the ESP32 will be connected to the positive side of the 470 microfarad capacitor, and we will ground the negative side of the capacitor. And this completes our wiring. Now let's go and check it out with WLED. And so now that we've hooked everything up, we're going to need to configure WLED in order to match our hookup. And so you go back into your user interface, power everything up, and you should be able to get into the user interface if everything has been connected correctly. And we'll go into config. And in config, we'll go to LED preferences because we need to tell it about the LED strip that we've hooked up. Now, if we go down here under hardware setup, we have LED outputs, and it's got a selection of different LEDs you can use. It defaults to the WS281X, which is the NeoPixels, and that's exactly what I have. So I'm going to keep it there, but if you have a different type, of course, you're going to want to select it. A very important thing is the color order, and there are a number of different choices. GRB is correct for the ones I have, and make sure you check on your strip to see what you have. Now over here is where I am going to have to change something. It says the length is 30 LEDs. I actually have 60 LEDs on mine, so I'm going to change that to 60. And another thing I need to change, extremely important, is the GPIO pin. Now I use GPIO pin 4, so I'm going to set this to, not 44, but 4. I'm going to set that to 4. Make certain you do that because it won't work without this. And that's all we need to set right now. So we're going to hit the save button, and we're going to go back, and we'll see if we can use WLED. And so now it is finally time to test out WLED. And when we first boot everything up, we'll get a solid color out of our LEDs. And that's because if we go into the control panel, we'll see it defaults to solid mode. And solid mode is the only non-effect mode. It just is a solid color. You can change the color. You can use one of the preset colors. So I can set that to red over here or blue if I want. I can also use this color wheel here and dial up a color of my own if I wish. But of course, we didn't build this just to have solid colors. We want to use some effects. And as you can see down on the side here, there are lots of different effects. In fact, there's so many, it could take days to go through all of them. But let's go and take a look at a more interesting one than solid. How about bouncing balls? And that's definitely more interesting. You can see that the LEDs are going back and forth like a bunch of bouncing balls. BPM's another interesting one. And BPM illustrates something that down over here we have an effect speed control that comes into play. So I can move this up over here, and you'll see the effect goes really fast. I can also, of course, move it down near the end, and it is very, very slow. And there are all kinds of effects over here. As I said, it could take ages just to go through all of them. Now, I will warn you, some of these are stroboscopic effects, and if you're subject to epileptic seizures or things like that, you don't want to run those ones. But there are still a lot of effects that aren't going to bother anybody, and they're really neat. Now, over here, there's another feature called segments, and you can divide your LED strip up into segments. I've got 60 LEDs, but I could make a segment with 30 LEDs. I could even offset the beginning of that segment and just control that particular segment. You can also save things as presets, and you can make a playlist as well. So this is really a versatile thing. And the mobile app has the same type of controls. So as you can see, with no code whatsoever, we have built a complete controller for LED strip lights using WLED. And so here's another demonstration. In this case, I've replaced my LED strip with one of the LED matrices I showed you earlier. Now the matrices are 8 by 8, so there are 64 LEDs on them, and the only change I needed to go into configuration was to go into my LED config and set it for 64 LEDs, because these are the same type of NeoPixels that my LED strip was. Now as for effects, I'm running one called Fireworks 1D, and you'll notice beside Fireworks 1D they have a little icon that looks like a matrix, and there are a number of effects here that have that, and so those ones are made specifically for using on matrix displays. But of course a matrix display is just 64 LEDs in this case, and so any of the effects will actually work on it. These ones have just been more designed to be matrix friendly, so to speak. So this is just another example of how versatile WLED is. You could cascade these matrices along with some LED strips and make some really neat effects. And of course with segments, you could have a segment that is a matrix, a segment that's an LED strip. The only real limitation is the number of LEDs you have and your power supply requirements. Of course, you might need to perform some power injection if you're using a lot of this stuff. So again, a great example of how versatile that WLED actually is. Now as it stands, WLED can do a lot of different things. It has tons of features, but if there's something that it doesn't do and you want to modify it, you can get the code on GitHub and you can make modifications to it. Warning, you'll probably need to use Platform IO or the ESP IDF to do this, because the Arduino IDE is no longer supported. One modification that was made a while ago is something called Audio Reactive. It allows you to connect a sound source, such as a microphone, to the ESP32 and use it to drive the lights. Well, Audio Reactive has now become part of WLED officially. You don't need to make any modifications, so it's already on that download we made. So let's go see what it takes to hook up a microphone and then use the Audio Reactive features of WLED. To add audio reactive capabilities, we're going to begin with the same circuit that we used before. We're going to add an IMP441 I2S microphone to the circuit. We'll begin by connecting the 3.3 volt output of the ESP32 to the VDD pin on the IMP441. Remember, this is a 3.3 volt device, so don't connect it to 5 volts. We'll connect our ground to the IMP441 ground, and we'll also ground the IMP441's LR pin. This selects whether the output is going to drive the left or right channel, and by grounding it, we're driving the left channel. We'll connect GPIO pin D22 to the IMP441 SD, or serial data out pin. We'll connect pin D25 on the ESP32 to the IMP441 SCK, or serial clock pin. And the ESP32 pin D26 will be connected to the IMP441 WS, or word select pin. Now if you're using a different ESP32, you can use 3 other I/O pins, as you can define these pins within WLED. Just stay away from GPIO pin 34 and you'll be fine. And that completes the wiring. Now let's go and take a look at our audio reactive WLED setup. Now before we can use Audio Reactive, we're going to have to set it up. So I'm in the user interface, and once again I'm going to go to Config, and this time I'm going down to User Mods. And in the User Mods setup, you'll see Audio Reactive, and there's a couple of things I need to do. You need to say Enabled, and then down here you need to tell it what type of a microphone you have. Generic I2S is fine for this, but you also have to define the pins, and these aren't the ones I used. And if you used a different ESP32 or just decided to use different pins, this is where you can make your selections. So for SD, I've actually connected mine to 22, so I'm going to set that to 22. WS I've connected to 26, so let's go and set that to 26. And for SCK, I've set that to 25. So let's go and set that to 25 right here. Okay, and then after that, we'll do a save. And we can go back. And we'll probably need to reboot. So after you do that, we should have audio reactive mode working on our WLED setup. All right, now we've all set up for audio reactive. We can go back into our control panel and choose an audio reactive effect. And you can notice which effects are audio reactive by observing a little musical instrument icon right beside it. And you'll see we've got ones like Reactives. We've got this ripple peak that I've selected right now. So let's look at ripple peak. And as I'm speaking, you can see all these different peaks of color in here. If I stop talking, the little peaks stop. And so this is responding to my voice. Now let's go up and try another one. I'm going to go way up over here. And here's DJ light. I like this one. It's completely off when I'm not speaking, and when there's noise, it starts to react. And of course, the more noise and the quicker the noise is, the more that it reacts. And so it would make a very good DJ light. You can imagine this would respond very nicely to music. So as you can see, it is definitely responding to sound, and audio reactive just adds another dimension to the things that we can do with the LED strips. Now, there are instructions on the WLED website for using things other than microphones as an input. For example, if you want to use the output of an audio amplifier, they will show you how you do that. Essentially, you feed it into the ESP32's analog to digital converter, and it works that way. You can also use analog microphones that way too. So audio reactive adds just another dimension to the amazing things that you can do with WLED. Now, one thing we aren't covering today is the use of WLED with Home Assistant, and there's a couple of reasons for that. First of all, the video would get way too long, but also I am about to embark on a series of videos all about Home Assistant, and those videos I'm filming right now as we speak, and you should see those in about a month or so. And one of the videos I'm doing for Home Assistant indeed involves WLED, so this isn't the last that we'll see of WLED. Now, if you want some more information about this product or about selecting LED strips, you'll find it in the article that accompanies this video on the dronebotworkshop.com website, and there's a link to that article right below the video. And while you're on the website, if you haven't yet, please consider subscribing to my newsletter. It's not any kind of a sales letter. It's just my way of letting you know what's going on here in the workshop and occasionally giving you previews of my new videos. Another way that you can get more information or discuss WLED is on the DroneBot Workshop forums, and you can join the forum very easily. All I need from you is your email address and a fancy username and your first name, and you're on the forum, and you can discuss WLED and all sorts of topics with a number of like-minded individuals. And if you're in a subscribing mood, please consider subscribing to the YouTube channel if you haven't already. I make videos about electronics and microcontrollers, and if you like this video, you'll probably like my other ones as well. Subscribing is very easy. All you need to do is click on that red subscribe button. You know where that is, below the video. And also, if you click on the bell notification, you will get notified every time that I make a new video. So until we meet the next time, please take care of yourself. Stay safe out there. Have fun with WLED. And I'll see you soon here in the DroneBot Workshop. Goodbye for now.